Given the quadratic equation, ax squared plus bx plus c, where a, b, c are the constant, has the roots of alpha and beta, show that alpha plus beta is negative b over a and alpha beta is equal to c over a. So we need to show this one, we need to prove alpha plus beta equal to negative b over a and alpha beta is equal to c over a. So let's start now how to prove ax squared plus bx plus c equal to 0. We start with the general form. Again, we are divided by a. This one is general form. Then divided by a. After divided by a, we will simplify like this. This is equation number 1. And then we will take the roots and put in the factors and we will expand until we will get general form. So x times x, we will get x squared times negative alpha x, x times negative beta x, and negative alpha times negative beta, you get positive alpha beta. So we will factorize the x. Finally, we will get the general form like this, whereby we can see the a is 1, b is negative alpha plus beta, and c is alpha beta. So we will compare the 1 and 2. The 1 here, a is 1, this thing is a b, coefficient of the x is called b, c is c over a. I'm going to highlight this thing, and this thing, inclusive of negative, right? Can you see that? So b over a is equal to negative alpha plus beta. That's why alpha plus beta is equal to negative b over a, meaning that we will write b over a is equal to negative alpha plus beta. So this negative bring over, so alpha plus beta is negative b over a. So we prove that we get this formula, right? And then for the c over a, compare with the alpha beta, that is why c over a is positive. Alpha plus beta is negative b over a, but alpha beta is c over a, which is positive. So we have proved that alpha plus beta equal to negative b over a, and then alpha beta is c over a by using general form and the roots of the alpha beta. Okay, using the roots of the alpha beta and the general form. First of all, we take the general form, we divide by a, we make it into 1, coefficient is 1x squared, and then we will factorize the alpha and beta. We will expand and make it general form, and we will do comparison the coefficient of the x and the constant. Then we get the sum of the root is negative b over a, and product of the root is c over a, right? So this is so-called sum of the root and the product of the root. So we call sum of the root is negative b over a, and POR is equal to c over a. This is a syllabus for the proving of the Form 4 syllabus and also Form 5 syllabus. So I will start with the first proving, start from Form 4. Given that function fx equal to x squared and the x is greater or equal 0 and gx is equal to negative square root x and the range of x is greater or equal 0. Find composite function fgx and gfx, hence determine whether gx is the inverse function of the fx or not. State your reason. This kind of question is called proving. So, solution. First of all, we have to start with the fgx is equal to the function f with the object gx. Alright, and we will substitute the function gx, which is negative square root x, inside, and the whole function will be square, and we will get fgx equal to x. Alright, first thing we will start with this fgx equal to fgx, and then let's go to the function given. Gx is negative square root x, so we will substitute in. Need to square the whole function of the gx. And if we simplify negative with square, we get positive, right? Square root x times square root x, you will get x. So that's why you prove that you got fgx equal to the x, which is the object. X is the object. Gfx, okay? Composite gfx. And then the gfx, the function gx is given here, right? It's negative square root x. So we have to use a function g, and we will substitute the fx. Fx was given x squared, right? Here. So the object now is a fx, and the function is a g. So negative is there, we will get negative x, right? So the gfx is given answer negative x. Because gfx not equal to x, right? So gx is not the inverse of the fx. So in order to prove that it is the inverse of the fx, we must show that we will get x. Since we are getting gfx is equal to negative x, so conclusion is gx is not the inverse function of the fx. The first proving is proving the fx equal to x squared and gx equal to negative square root x. Find fgx, find gfx, and then determine that gx is the inverse function of fx or not. State your reason. So we found out that gx is not the inverse function of the fx, because if it is the inverse, you will get the x.